Well, hey there, kiddos. Today we're going to talk about association versus causation, and that's a bunch of words. It's a lot of stuff that's being said. We're just going to talk about, when we talked about correlation in class yesterday, we talked about, does something have a positive correlation or a negative correlation or a no correlation? And then so we're going to talk about how data is associated. And just because two sets of data correlate, so they have a positive relationship or a negative relationship, doesn't necessarily mean that the two things are related, that they have any association whatsoever. And just because they have an association doesn't mean that they have cause. It doesn't mean that they have cause to be related. It just happens that the data shows that they are. And so we're going to talk about some of that and look at some problems that have association but not causation, and some that do. So your first question here, you have two shop owners that are comparing their sales for the last 8 days. The owners seem to notice a correlation between their sales. Compare the amount of sunglasses sold and total ice cream sales for the 8 days shown below. So you have a data table that shows you which day it was and how many sunglasses got sold and how many ice cream got sold from two different shop owners. So step one, we're going to graph the ordered pairs. We're going to do sunglasses on the x-axis and ice cream on the y-axis, and we're going to make a scatter plot. So we're going to pause for just a second, and I'd like you to make a scatter plot on your graph using that data. So hopefully you have a scatter plot and you have plotted your points and you can see now what's going on. So step two is to write a linear function that provides a reasonable fit to the data in the graph, and this is where you'll need your calculator. You're going to use your calculator to make a line of best fit. So you're going to do what you did yesterday or the day before, and you're going to take those values and you're going to put sunglasses in list 1 and ice cream sales in list 2, and then you're going to do the linear regression and then round to get the answer. So take just a second to do that with your calculator. So I've used my calculator. I've found the linear regression here, and so I've got my A and my B, and I can see by my correlation coefficient I've got a 0.95 correlation coefficient, and so it means I've got a pretty strong regression, so I'm good there. So here's my equation. I've got y equals 2.94x minus 139.98. So I've got to calculate the correlation coefficient, which I've already done. It shows right here it's 0.95. So r is equal to 0.95. So it has a pretty strong correlation. That line shows that those two data sets are correlated pretty well. So step 3 says, do you think buying more sunglasses causes ice cream sales to rise? Yes or no? Now there's not a right or wrong answer here. I just want you to think about it and have an answer, and so we can talk about it when I come back tomorrow. So just think about that step 3. Come up with an answer, yes or no, and then why or why not. Make sure you have something written down before you come to class tomorrow. So let's compare and contrast and talk about some definitions really quick. So we're going to compare and contrast association and causation. So association, causation occurs when a change in one variable produces a change in another variable. So one thing changed and it made the other thing change. And that's not just that they're both changing, it's that one thing changed and it caused the other thing to change. And so that's what makes causation. For example, the temperature and snow on the ground. If it gets really, really cold, you can have snow on the ground. So if the temperature drops, it could cause snow to fall and be on the ground. If the temperature rises, it could cause snow that's there to melt and not be on the ground. So there's a cause, it happens. But your height and your grades, they don't have a causation necessarily. You could be really tall and it not cause your grades to increase or decrease at all. They don't have a causation there. Association or correlation, they're the same thing. If something has a correlation, then it's associated. If the association happens, it can be observed between many variables, like our sunglasses and our ice cream sales. But causation can only be determined from data collected from a controlled experiment. So the experiment has to be an experiment that was done by a scientist, and it had to be in a controlled situation, and that's the only time you can determine if there was a cause, if this one thing caused the other thing to happen. So causation occurs when the change in one variable causes the other variable to change. Association is the correlation, and it happens, two things can be associated but not have causation. So we have a new question here. So you have a graph below that shows the association or the relationship between the per capita, that's per person, the per capita consumption of margarine in pounds to the divorce rate in Maine per 1,000 people. The correlation coefficient for this data is R equals 0.99. So it's got a pretty strong correlation coefficient. It's got a pretty strong association. So number 1 asks us to describe the correlation represented by the situation above. So if you look at our graph, the correlation that it has is definitely a positive, a strong positive correlation. You can see it increases as the consumption of margarine increases, the divorce rate also increases, and so the two they have a nice little association. So as the consumption of margarine increases, like we just said, the divorce rate in Maine also increases, which makes it have that positive correlation. So according to the chart, margarine consumption causes divorce rates to increase. Do you agree or disagree? So think about that for a second, and then turn to your shoulder partner and talk about it for 1 minute. So hopefully you've had a discussion. There's not necessarily a right or a wrong answer, but I'm going to say that I disagree. I don't think that the consumption of margarine affects the divorce rate. I think that there's more involved between a husband and a wife than how much butter someone eats. But you could have had a different reasoning. I hope that you had some good conversation, and we can talk about this more tomorrow. But the two are associated, but they don't have any causation, because in a controlled experiment, I doubt anybody did an experiment to see if someone ate a lot of butter, did they also get divorced. It seems like a weird experiment there, but there is data for it. But the two things are associated, but there is no cause. The consumption of margarine did not cause the divorce rate to go up. So on the next two, we're going to see if there is likely to be an association. Are the two things going to have a correlation? Are they going to show some sort of relationship? And if so, is there a cause? Is there causation? Did one of them cause the other to happen? And we're going to talk about it. So the cost of a family's vacation and the size of their home. Well, if I were to plot this on a graph, as the cost of a family vacation goes up, it is possible that the size of the person's home could go up. It's also possible that the size of their home could go down. But I would think that as you went on and you want to graph that, there could be an association. So yes, they could be associated. There could be a relationship between the cost of a family's vacation and the size of their home. So they own a really big house, they can probably go on a really big vacation. Own a really small house, they're probably going to go on a really small vacation. Not necessarily, but they could be associated. There could be association. So yes, there is association. You could definitely have association between those two things. Is there causation? No, because the cost of a family's vacation does not cause the cost of their home to increase. So, I mean, it just doesn't. They could pay a whole lot for a vacation and their house be paid off. So the cost of the vacation does not cause the price of the home to increase. So it doesn't cause it, like our definition said. So no, there is not causation. Because one did not cause the other. So number 5 here, the time spent exercising and the number of calories burned. Well, we can definitely discuss this. The more you exercise, the more calories you burn. That is a proven fact. Everybody knows it. That's why shows like The Biggest Loser are so popular, because those people, they go in and they work out a ton and they burn a whole bunch of calories, which causes them to lose a whole bunch of weight. So yes, there is definitely association between these two things. As one increases, the other also increases, so you have a positive association, a positive correlation, and there's causation here. It is proven. There have been studies that shown that the more you exercise, it causes you to burn more calories. And so there is definitely exercise causes calorie burn. One causes the other to happen, so yes, there is causation. So hopefully you can see the difference between two things being associated but not having a causation, and things being associated and there is causation. So one of the things has to make the other thing happen. If it doesn't cause it to happen, then there's no causation. So that's it. You're going to work on your practice now. Everything will be due tomorrow. I'll be taking homework packets up tomorrow after we do our activity. So please make sure you have everything done. I will see you then. Have a good rest of your day.